Good morning. I am Vince, reporting for Thermistor. There is a numerous design variation for thermometers, but these two are typically used, the more durable fixed variant as well as flexible version. A thermistor is just a thermal resistor, which is an electrical resistor whose resistance varies with temperature. However, there are two different types of thermistor: NTC or negative temperature coefficient, and PTC or positive temperature coefficient. As we observed previously, a metal resistance tends to rise as its temperature rises because the atom began to vibrate, which makes it more difficult for an electron to get through the substance without colliding. This is how thermistor of PTC kind operates. We refer to it as a positive because a resistance temperature plot reveals an upward trend that indicates an increase in resistance with temperature. As for the NTC or negative temperature coefficient, an alternative type. With this type, we employ a semiconductor with slightly different behavior. This type will actually decrease in resistance when we plot the resistance of temperature. We refer to it as a negative temperature coefficient. This has to do with the way the material atoms are structured. A metal atom's simplified structure shows the nucleus at the center, followed by several electrons that are all in various orbital shells. An operator has 1 to 3 electrons in its outmost or valence shell. Each shell holds a maximum number of electrons. An electron has to be certain amount of energy to be absorbed into each shell. The most energetic electrons are the most distance from the nucleus. In order to the substance to conduct electricity, electrons must be able to follow between other atoms in the material. The nucleus holds electrons in place, but if they can get conduction band, they can escape and migrate. Conduction band and the valence shell overlap with the metal atom, making it exceedingly simple for an electron to break loose and migrate. The outmost valence shell is filled with an insulator. For an electron to join, there is extremely little or no room. The conduction band is far away from the nucleus as a firm hold on electrons, making it impossible for them to leave. As a result, electricity cannot pass through the substance. However, a semiconductor will act as an insulator because it has too many electrons in the outer shell to be conductor. However, due to the close proximity of the conductor band, if we heated the material, some electrons would have enough energy to jump and separate from the atom. Since the resistance of the material reduces as the heat is applied, its basic structure is just a semiconductor sandwiched between two conductors coated with protective covering. And that's it. Thank you.